Hi students, this is your video for homework that will be due on January 28th. It's on solving systems of equation by substitution. Let's go ahead and get started. I'm going to do 4 of the problems in there. You're responsible for doing the other 5 problems that are on there. Alright, so in substitution we learned that you have to get one of the equations and isolate the variable. So let's look at equation number 1, x equals 2y. This already has x isolated on the side, and so that means this is ready for substitution. If x wasn't by itself, we'd have to do some solving work right here to get it solved for one of the letters, but since it's ready, we're ready to go ahead and go to equation 2. X minus 3y equals negative 10. Okay? So since x is equal to 2y, we're going to take out x and we're going to put in this 2y in its place right there. And so this is what it'll look like. The x goes away, 2y goes in its place, minus 3y equals negative 10. We've substituted, now we have to solve. So this is just combining like terms. 2y minus 3y, 2 minus 3 is negative 1y equals negative 10. And then when it's beside it, we divide it. And so y equals negative 10 divided by 10, by negative 1 is positive 10. And this is half of our answer. This is the y answer, so that's 10. Okay. Find the other variable means we're going to take this 10 and we're going to plug it back into one of the equations. It's typically easiest if you plug it into this one that's already been solved for. So I'm going to take out that y and put 10 in its place. And so this is what it will look like over here. X equals 2y. I'm going to take out the y and I'm going to put this 10 right there in its place. And so this will say x equals 2, the y goes away, 10 goes in its place, and then we just multiply. 2 times 10 is 20, and so our answer is 20, comma 10. And you might even see it written like this. X is 20, y is 10. Okay? But that's an ordered pair up there. Alright, next. So the next problem, we get rid of the design for you, so you have to be able to figure it out yourself. So what we look for is, when we look at the two equations, equation 1 and equation 2, is one of them already solved? And this one is already solved. That means that that right here is ready to be plugged in to the other equation. And we're going to take and we're going to put it right there in those parentheses. So this is going to go right in there. And so this is what it will look like. 4x minus, instead of y, we put in negative x minus 4, and everything else just stays the same. The 4x minus, the equal sign, and the 4. Right here, this is a double rainbow situation. This, we add in a negative 1 right there, and then we're going to double rainbow. So this becomes 4x. Negative 1 times negative x becomes positive x. Negative 1 times negative 4 becomes positive 4 equals 4. Put a 1 back in front of this. 4x plus 1x is 5x plus 4 equals 4. Subtract 4 from both sides. And now I'm just going through the solving steps here. That cancels. 5x equals 4 minus 4 is 0. 1 is beside it, we divide it. And so x equals 0. There's half of our answer, so we know that it's 0, comma, something like that. Then we're going to take that and we're going to plug it back into either one of the equations, but remember I had said in the beginning video that it's easier to plug it in to the one that was already solved. So we're going to bring it right here in those parentheses. So it'll be y equals a negative symbol. Then here's those blue parentheses from up there. Minus 4. So y equals, the opposite of 0 is 0, minus 4. 0 minus 4 is just negative 4. So negative 4, 0, negative 4 is your answer. There's your x and your y. Okay. Alright. So now we put it in the context of a word problem. So you've got to be able to read the word problem, figure out which of the two equations A and B is correct, and then solve it. Okay. I just learned that there's an error here. This is the same thing as that other problem over there. It should say using the equations above, what are shouldn't say dimensions of Vicky's garden. It should say what, should say how many red and green rulers were sold. Sorry about that. Alright, so a total of 35 rulers were sold. So both of them have 35 rulers being sold. It is $2 for a red, so we need 2R, so that means this one is now no longer correct. When we look at the two equations here, neither one of them is solved for R. But what I notice about this top one is that it doesn't have any letters in front of the R or G, so that makes it's going to be easier to solve for a letter. So R plus G equals 35. I can solve for either letter I want to. I'm going to go ahead and just solve for R, so I'll put a box around R. I just minus G to both sides. G cancels, and so I get R equals 35 minus G. Now I'm going to take this and I'm going to plug it into the other equation for R. So here's the other equation, 2R plus 3G equals 82. So I'm going to come right here where the R is at, and I'm going to replace it with 35 minus G. So it'll say 2 parentheses 35 minus G plus 3G equals 82. Double rainbow. 2 times 35 is 70. 2 times a negative G is negative 2G plus 3G equals 82. Combine the G's. So this is 70. Negative 2G plus 3G, that's negative 2 plus 3, that's 1G equals 82. I'm going to bring it up here to the top. 70 plus G equals 82. Minus 70 to both sides. And G equals 82 minus 70 is 8 green rulers. Then we got to take that and we have to plug it back in, and it's best to plug it back into this solved one right here for G. So I'm going to take out G, put 8 in its place, and so it'll be R equals 35 minus 8, and 35 minus 8 is 27 red rulers. So there's your answers. 27 red, 8 green. If you add them up, 27 plus 8 is 35. If you multiply them by $2 for the red and $3 for the green, you get $82 spent. Okay? Pretty involved problem, pretty tough, but that's as hard as they get in terms of these substitution problems. Alright, last problem says McDonald's sells Big Macs and double cheeseburgers. One day McDonald's sold 15 more Big Macs than double cheese for a total of 35 hamburgers. Would it be reasonable for McDonald's to sell 9 double cheeseburgers and 26 Big Macs? And so then you have a couple of options here. So we did this problem the other day in class. We set it up and we called them X's and Y's. So I'm going to let double cheese be X, Big Macs be Y. So together we sold 35. 15 more Big Macs, so that starts with Big Macs as Y equals 15 more is plus 15 to X. So this is already solved, so we're going to take and plug that in. Y goes into right there. So it's X plus 15 equals 35. X plus X is 2X plus 15 equals 35. Subtract 15 from both sides, and 2x equals 20, so x equals 10, so that is 10 double cheeseburgers. And then if we plug that back in to right there, y equals 10 plus 15, y equals 25 Big Macs. Okay. Then it asks us, is this reasonable? Yes, since the number is 35. 9 and 26 does make 35, but the correct answer here is B. The number of cheeseburgers is not 15 more than Big Macs. So this is the correct answer. It is no. That's not a reasonable solutions, because the difference between 9 and 26 is 17 and not 15. Okay, remember to make sure you finish up all of the rest of the problems on your own and bring this in completed so that you get your 100.